In this video, we will discuss beam of uniform strength. Uniform strength means stress value should be same with respect to length of the beam. So at each and every point, the stress value coming should be same with respect to length only. Here, if you see this first beam, where we are keeping the thickness constant, and with respect to length, this total length L, we are varying the width of this beam from B to 0. So right now I have drawn it linear because the final result is coming out like that. But just if we are taking some random shape and saying that B at x and thickness T will remain same at x, there is a load P applied on this point and other end is fixed. So some random width which is B at x, thickness T. So if we draw this cross section, then B at x and thickness T at neutral axis, which will be at the center line, inertia x will be bx t cube by 12 from this rectangle. Now moment at x is p into distance x. So at this cross section, moment is p into x. Now if we calculate stress my by I, so m at x, y upon inertia at x. So if we keep this value px at a place of mx, y is thickness divided by 2. So this distance, half distance of this thickness, that will be y divided by I at x. So I at x we know bx t cube by 12. So if we keep this value and evaluate this, then it will be 6px divided by bx t square. Now stress should be same, so stress should be constant. Now if stress is constant, then if you subject b at x and if we write the equation, then b at x is 6px by t square c will go at the denominator and b at x will be here. So b at x, we know this p6 c t square all are constant, only x is varying. So b at x is proportional to x, so it will coming out as linear. So this is the linear shape where b at x is varying with x, so b at x will be b x divided by L. So this will be linear relation. So it will be having this kind of shape, triangular shape, and if we apply the load, then the stress will be same at all the points along the length. Stress will vary in thickness from neutral axis to the farther point, which is y maximum, but it will be same throughout the length. Now here, if we see, if we replace b at x with bx, you see my by I, px t divided by 2, I is bx t cube by 12, b at x we know now, bx divided by L. If we place that, then we see 6pl by bt cube. So this all values are constant, so stress is now coming out as constant value throughout the length. The other case is where we are varying the height, we are keeping. So here thickness was constant, now it is varying, and width is constant, so b is constant. So p is the load, total length is L at some random point x. If we draw cross section, then b will be constant and hx will be varying from capital from this h to 0. So in between anywhere hx is there. So for this cross section, if we write moment at that location, then it will be p into x. P is here, x distance, p into x. Ix will be b h x cube divided by 12. Hx is some random point in between the beam where the random height is there. So now we have to find hx relation with x. So if we place in sigma my by I, so mx is px and y is hx divided by 2 for this cross section, and we know inertia b hx cube divided by 12 for this cross section. Now if we evaluate this, then it will be 6px by b hx square. So this stress should be constant. So if this is constant c, and if we make subject as hx square, then 6px upon b into c. So if we take root on both side, and you see here c, b, p and 6 all are constant, so we can write hx square is proportional to x, and if we take root, then hx is proportional to root x. So this is the equation of parabola where hx is varying as per root x. So this will be the shape of this beam if we are varying the height. There are other cases where these both are combined, but they are asked in very less in the exam. Both these cases are important because we have linear relation and parabolic relation directly. So remember these relations and shapes directly, no need to remember the calculation. This is for just some questions if they ask in interview or somewhere else. So thank you for watching this video and see you in the next video.